The Leeza Soho Tower by Zaha Hadid Architects is a great precedent to study parametric design. The unique facade pattern that creates a spectacular atrium may seem complex, but is simple to script with the right code. In this video, part of the Rhino Essentials Guide, you'll learn both how to create the Soho Tower in Grasshopper, and you can both check the description for the full course, where you'll learn how to create the tower in native Rhino and Revit geometry.
Right, so I've actually divided this code already into some of the sections that the code would have. I made a section for input, one for the functions of the level, just creating levels, also one for surface pattern, one for paneling functions, and one for floor plate functions. We'll just do one at a time. And so right here from the input, we already know that we're going to bring the surface in. Now the thing is, we're going to really divide it. And we'll need to have a bounding box that's gonna fit it. And so instead of sort of trying to figure something out that'll take too long, I'm actually just gonna create a rectangle, and I'll just sort of develop the points. This is very simply, so as to not to having too much issue. And of course, I find it very valuable to use just a few functions that we're going to be looking at in the class. So I'm actually just going to be using Elefront and also paneling tools. And those two plugins are pretty standard for Grasshopper, so they're not going to be causing too much issue. And so I'm going to use, like I said, just a rectangle here. And so I sort of got it started here, just verifying that I'll just use the right one from this basic categories here, and we already have it. As you can look in the sort of file, it's not really known, but we know this is about 100, and I just need it bigger than the size here. And so what I'm just going to do is do 200 by 200, and since I started at the origin, it should be fine. And just check to see what that is, and I'm gonna go ahead and turn off my site. I don't need the site or massing for this part of our exercise. All right, and we just look to see sort of where that is located, and we'll just make sure that the units are going to be in feet, because that's what we're going to be using in rhino.inside. Is that we're just loading that preferences, and pretty much we should be fine after that point. So making it in feet. All right, so we're fine, we're good. And I just will sort of hide my model geometry while we do this, and just sort of check what's happening sort of here. Would sort of turn into a curve from this situation here. And so as we sort of look out, sort of to find out where's our rectangle, we see that it's not really centered. And so one way to center it is really sort of to move it sort of to the origin. And one way to do that is just using area. And we use that area function. Area function that, of course, can very simply be found if you're sort of typing in. You also have the different options, just using polygon center as well, so just to find that center. Okay. And so now we just have that center. We would just move that center to 0, 0, 0. We could just find that by using a construct point. And we're not really going to go over too much of just Grasshopper scripting, because we're definitely trying to get this to get into rhino.inside, and I'll keep expanding out to find where I need to go. So I'm moving my polygon for my surface from here over, and so what we're going to do here is just move to point, and we just have our point A and our point B, and from this regular center to point B, and just moving that. And so now we have something, and we'll just look in our plan view. It's already over the area. And so this is where we're now starting to work with our levels. And I just will spread things out again. We're avoiding, that sort of too many elements all around the model. Again, we're trying to keep things clean. All right, so what we're going to do now is with our floor height, we're going to be using a series. And from this, and this is found in the sets tab here, we're working on the sequence. And we'll just really be using, going from 0, and we're just going to be working on our floor heights. And I'm going to click from this floor height into, that's actually my step. And we're doing 47 of these. So it's a way of us splitting this particular time. I'll use my panel to sort of plug in, sort of see the values we get for our levels. So and this is going to be what our level is going to be. All right. And I'm going to go ahead and turn off my icons for now. You can see all the sort of titles I have. And it's fine to sort of have it, but it's obviously useful to sort of see what's going on here. All right, so these are going to be my levels, and I've already placed sort of a value for that here. And we're going to actually pull these two values back, just so we also just have that labeled, the floor height and the floor count. We're going to take this value and we're going to plug it into building levels. And again, we're giving lots of space, again, thinking for productivity and working with others as you work on these codes. We're going to plug that into our building levels. This is pretty much everywhere there's a level. All right, and so obviously the last one, it should sort of go up above that. So that's just a note that we'd actually want to actually include an extra one, not for the sake of the building levels, but actually for the roof. So what we can always do here is just add to this array, and you could actually simply do that with list. And we're just sort of inserting an item at the top. And we're just going to be inserting sort of, if you would sort of see at the top, and we'll just do like the quick calculation of this. We do 47 times our floor times the height, and that's going to actually be where our roof is. Okay, that's 622.75. And so our top here goes 609. And so we'll just add that item, and it's going to be at the height or the top of that. So we'll just do the list length. Just type that in here, and there we go. So that's going to be the top one, and so it can't really go until it gets that information. So it's going to be at 47. End this here. Now we have 48 values. Okay. So again, this is just for our splitting of the main surface. Okay, and we're actually going to again just nicely organize everything down, so we are avoiding too many just wires all over the place. And it's essentially like a component. Just take that and take it away from here and just sort of lower it here. And now we're going to divide that surface. And again, what we wanted was to have the nice geometry that would be doing that for us. And we can of course come back over here and turn off preview. And for this one we're going to be going through and just moving it to each of these points. We're going to use this data again. This is from the transform menu, where we just take our new geometry, and we're going to use our levels, so the transform levels, and just make sure we have enough of this here. And this actually could be all on sort of the level function. So I'm going to bring that back here, though it has sort of two sort of separate bits that work together. Okay, and so we're going to take this list, and this list is actually going to be converted with a unit Z, so to show where is it going up. We'll just plug that in here, and of course we could also just use a number to sort of say floor levels, and I do have that variable as well. But this is actually just could be sort of the same one. You could even just copy it, but I think obviously using the name is useful there. Building levels, right? And so this is just sort of section levels because it includes the top, right? And we'll just use that as a factor, and we're gonna be cutting this after sort of doing this set of values. And also because obviously we actually want to be slicing this, we're actually going to go ahead and turn this into a surface, and that's sort of our cutting plane, and we can label this here. All right. And one way obviously to get a surface is actually just plug this directly into the surface function. So that does the same thing as boundary surface. And that's the geometry we want to go in there. We'll go ahead and hide it. Preview, turn the preview off here. And the thing we want to do is just to go and cut this form using that, and that's going to be using our transform, intersect function. And so we'll just be using our 1B rep and cutters. And so you just see split B rep with a bunch of other items. So just get your cutters here. These are all of our cutters, and our main surface is here. And we can even sort of pull a lot of our level function items down. So it sort of gives a little bit of space there. And this whole set is easily placed down. We can even group it because now we have sort of a place for our levels, but we're almost done. I'll just go ahead and group it now. So that's our level function. We've gone ahead and created sort of our function. I've grouped this, but I removed the first sort of intersect because we actually want the physical intersection instead of just the shape. We're going to use multiple curves, but actually it's really with B-rep and B-rep. And so the idea is it's going to intersect our base surface and these cutters, right? And so it doesn't have to really be in front of it. I'll just put that there. So now we have all the curves that are going down, and we'll use that to loft and recreate that surface and work on panels and offset and come on to the curves. And so the last sort of bit for this one, this sort of part of the function, is just really to get our facade curve, and we'll just copy it down here. And so we have our facade curve going on here, and we're just to put our output sort of from this function here, and we actually could go ahead and just put this sort of into the function, but we're gonna just drag out our building levels because this is going to be important in getting this into the future workflows. And we'll just pull this out here and just shortly get to the end here. And so now we have our sort of output that we have here, and because the curves are just going straight up, there's no real reason to sort of have it in a array. It's just straight up curves going up. All right, and so you can just click on these and add these to that group. And this is just our level function. And so the next thing that we'll be working on is going into our surface patterns. So now we'll work on getting our levels into pretty much a workaround for the surface. And the great thing about this is it's going to be more controlled for us. The idea just really helping us to find how do we want to sort of divide these curves, because the idea is we don't want to just make lines down to split the surface. We really want to just have it more controlled about which level does what. And so the first thing I'm going to do here is we're going to just plug in our surface function to our surface pattern function. So it's going from our facade curve from the levels function to a surface pattern function. And so I'll talk about some of the things we're going to use. We're going to be pretty much lofting up, but we need to be sort of dividing these. So I'm actually going to use the divide curve function. But actually, we're really going to be doing that after we're working on pretty much using the domain for each one of these. And so one of the things I'll do here is just really use evaluate. But I'm going to pretty much be in the curve menu world here. So we're working to evaluate the curve position, and I need the domains for each one of these. And so it's really the curve domain function, which you can find in analysis. And I'll just be looking for each one of these sort of domains here. And I'll just quickly hit this. Now, the idea is because of how they're made, sometimes they don't all have the same sort of domains. Some of the domains might be a little bit different. This one, everything seems to be fine, but sometimes it doesn't. So it's good to always check that. So that's 40, about 48 of these, and it's hitting the right domain type. Now I will say, I will just choose a value between 0 and 1. So just like a regular number slider. And I want to choose a domain. I would just actually relate that domain to here. And we're just going to use our remap domain function. That's from the set menu. And we'll just remap it to this domain, right? So this is our source, or pretty much our target domain, our source domain. We actually can even plug this straight into the source. And the idea is, and I'll just pull it out here. So to see what it's going to do. And actually, I think it's more of a, we do number slider and just make sure that goes all the way to 1. And so it can go from my least to my maximum. And so that's going to help me just really quickly get a point. And so I want to evaluate these curves just to see that and make sure that I'm getting the right point. So let's use the evaluate curve. And pretty much each one of these is going to be evaluating to that same mapped coordinate. So that's helped me figure out that everything is sort of working the same way. Okay, that's my first step. And what I'm going to do, and because we're really going to take a little while to get the paneling, is we're just going to use that base for us. Now I actually have a function, and I'll put it in later, that will help me to sort of stay within this subset here. For this class, I've created some helpful functions, and you'll find that in the special functions include here. And I'm going to use the domain constraint function for the current, and we'll just come back over here. And so that domain constraint function is going to be really useful as I am starting to play around with different surface patterns. For instance, we were trying to get things to go in different directions. That's going to be really helpful. Okay, so now that we have our domains all sort of working the same, we can start to play around. And the first thing we want to do is and we'll be using this remapping numbers a lot. For instance, now we actually want to, and we will actually, the best way to do this is actually just bring down all this together. We actually want to now develop a little sign pattern to sort of develop that differentiator on this side. We actually want to also do a shifting of that value. And so that's going to be where it's really important to make sure that this is in the curve domain. All right, so the first one for our sign value is we're going to make sure that this sign value is going to be not taking up the entirety of the domain. Okay, so you could even say that if I would really want this value to be like pretty much this is like the whole curve is at 1, 0.5 is less of that, and maybe I would even do 0.1. And we're going to get the values. We're going to start here, and this is going to be our end function. All right, so that 0.1 is time the sine wave. And the sine wave is actually going to connect to the levels. We'll put the sine function in. That's from the math tab, right? And we want to really be doing the values from 0 to 90, because we're not sort of doing the sine wave below, we're just doing the sine wave above 0 to, and it's actually 0 to 180, okay? So that 0 to 180 is what we're gonna get, and we're actually not gonna use the building levels. We're actually gonna use directly our function that's telling us the floor numbers, right? We actually don't really need that value. We could actually just do the same thing by just looking at the list length. And because it includes the top, we're gonna go ahead and make sure that that list length is actually from here, right? And it's actually gonna minus the value just because of the raise in Grasshopper, okay? So this is gonna be our set of going to 0 to 180. And we'll just add 1 here, and we'll already put 1 in there, so we'll make it 48, right? So this is actually going to be our same of 0 to 180, and so we essentially are making each one of these pretty much it's 180 divided by this value, right? And we just go ahead and just do that as a panel and use our division. Place this below here. And pretty much each of our sine is going to be divided by that, right? So it's going to be 0, going all the way from 0 to the top. Now, the only thing we're going to make sure is we're actually going to start a little bit offset because we want the smallest panel to connect down here. And that's going to just be like a little bit of a little feature that we have here. And so the way we're going to actually do that now is you're seeing that we have like a sort of divisor, right? And so this is going to be that 48, and actually we're trying to get values between 0 to 180 from this function. And so essentially, you know, again, it's a little bit of math here, and we're going to be using the sine function at the last for the values we use, and we just need to click here and make sure it's in degrees, so it'll be correct. And the thing is, what we want is a series at the edge of this, right? So we're going to 180, and we're just trying to make sure we have the right step. And the count is definitely going to be, again, this 48. Right, and so now we have just the regular 0 to 27, but we want to use, we're actually going to flip these, right? We want to use more of a 3.75, right? And that step's going to give us that number 0 to 176. And again, like I said, we actually want to start a little bit before this because we actually want to avoid, and I'll just put it in here, avoid sort of our intersection, because when we come back and make our wave, we want to make sure that we can start at the bottom. All right, so I've got those values. I'm going to put those into our series. And so this is a series of numbers that's going to be giving an offset from the base, right? And the thing is, until it's multiplied by a number, it's just going to be the regular 0 to 1 for a sine curve. So we're going to just take that and now multiply it times our value here. And so to make things simple, again, we just spread things out, and we can even just sort of pull some of the things back here. We're just sort of this is sort of representation. We're actually not going to really use that, but we'll multiply our sine result times our percentage of this. Now, the thing is, we also can multiply the sine directly with sort of that in value, right? So the concept is we're starting on this particular point, and we're adding a particular amount plus, right? And so again, my goal being saying that I really need, this is really my limit, my maximum. That means that this maximum is going to multiply times here. And so the idea times the sine wave, if we pull that in, like again, we could sort of do this on different sides. It's actually, we'll do the same function, but I'll put this in here, and you're not gonna really see it till I go ahead and evaluate the curve. And we'll just leave those evaluate sort of in the same place right here. Okay, so we're gonna put that evaluate curve here, and we're gonna come back over here, and the idea is, as you can see, all these sign functions are positive, so that's a good look. We're gonna take the map parameters and bring them in here, and you can see it's actually stepped over a little bit because we need to have sort of if we're going to relate to this previous function, we need to make sure that we're actually starting at the same place. So I'm going to go ahead and see, this is our base. I'll just plug this directly back into here as my value source, so you'll see where the sign is coming from, right? Okay. And so we actually have this base sort of starting on the other side, though it's really here that we really want. But that's our base. And all we really want to do, if we're going to use the same curve, is we actually can just go ahead and just do a reverse of it. So we'll take that same set here that we've just done in this direction. And we could even just sort of do it where we sometimes you can actually do it on the other side of the curve, but we're going to just copy this, and this one is where we've multiplied and sort of added it. And the alternative, again, because it's at that 0 point is where we started, is as it's starting to go negative, and that's fine for us, where we are now going to say the value is really the lower bound minus this, and that could be simply done by just multiplying by -1. And so we have -1 here, we have that going in, and that we put that value in. Now it's going to be a little different here, and so this is actually another way we actually can avoid sort of using my custom function, actually, though I really do like this function. If you're starting to see now, we're going into negative numbers, and we really want to come back. We could always just say now our source domain, and we'll just construct it here. We're actually going to be essentially going from the other side, right? So it was first 0 to 1, and now we're having a domain where it's actually, and I'll just sort of show this here, it's -1 to 0. So that's going down a little bit, and it should work. And I'll just put this as our source domain, and we'll just evaluate the curve in that same vein, and we'll just put that in here, and there we have our value, right? And so I have a custom function that you also sort of play around with if you give it a value outside of the domain. If you do it on this side, it might have an issue, but if you do it on this side where you just add a value to it, it would have another value. Okay, so the next thing that we're going to do is, because for this sort of the way this curve is made, again, we might want to sort of rotate this, and that's also sort of a place where we'd start to actually need this function, because like what if we don't want it to go through this sort of long end, we want it to go to sort of the middle, we want to rotate that domain value. So what we would do is start to figure out, what does it mean to rotate it. Essentially it's going to be taking the domain it has, and we're just going to add it, and then we also want to be shifting it. So it's really going to be just an adding and shifting sort of thing. Okay, so we have the value here, and we're going to get to the other side, but we really want to have pretty much that start point. And so this is another way of sort of setting that start point. And again, that's actually where we would need sort of that bigger domain function, because we're going to be adding Whereas currently it just started here. If we start adding this value, we can start to get some funky domain stuff happening here. And so if I would just use the same remap numbers, and actually I'll just make a new one. It's going to use some of the same base information, but and I'll even just sort of plug that in as the target. The issue is if I want to rotate this, I'm just going to tell you what value of rotation I'll do. And so I could still sort of do my 0 to 1. In here, but the problem that's going to emerge is if you add these numbers before the domain, what we can actually do, because we want to keep in that location, we're gonna just have a little more of a benefit of getting it into here. So I'll just do that so we can figure that out. But essentially I'm adding domain values. And so essentially this will make that domain a lot higher. So now I will plug it in even to here. And the thing that is finding that you'll find here. And again, even right here, the thing is, I wanted to maybe sort of avoid sort of doing this in two different ways. So this is where it starts to, get a little clever in where you're really adding this value to both of these, right? And I'll do this first here at the parameter. It'll give an issue because it can rotate it. It can figure out where that would go. But the fact is outside of the domain is a bit of a problem. And if I remapped this one, then we'd have a little bit of challenge because this value will be, it'll be working within that same of the previous domain. So because I actually want this particular location for it, that's my key point, right? Because of that desire, what's going to happen is I'm going to really need to have a function just like I've made here, domain control, where I will keep things within my particular domain that I started with. It's my target domain. And I'll just sort of start it up here. And just keep that here. And I'm going to just sort of create that as, this label as this as my src domain. Pull that domain into here and start saying, let's get this back here. And also, if you notice, it sort of took my previous value and it sort of made it into sort of a single line. Well, that's going to be more resolved here. And so the way this function works is my a value is going to be the particular, new end domain value, and B says if it's less than or more than, and C will give like a bit of a Boolean filter so that if you want to use that for a function. Okay, so I just plug this in now. That'll be my new parameter. And now it's neatly organized without giving an issue. Right, and it also solved it because it was over the domain and it just turned into a straight line. We have it there. All right. And so I'm doing that addition on this one. And I'll just pull my evaluate curve out again. This is just my first function to add to here. And I have to do this for each one. I'm adding my base value. And then I'm going to add this sort of function to come here to work on this one. And so now, so both of my evaluates can be there. All right, so I'm going to just plug that in. And so now we have a very simple function to be rotating just right here. And I'll label it so it's easy to find. See where we rotate it around here. And so we'll make the other curve on the other side. So now we're going to be labeling sort of our functions here. And so we know these are our remap functions and are just sort of maybe sort of inverted. We'll just pull this out here. So this right here, down from here, is all our functions for this is our rotation up here. This is going to be our sine function, right? And as I said, it's sort of nicely separated out. What we're going to do is sort of graft adding a value here. And so what we're going to do is really just base off adding 0.5 to our sort of rotation number, and just graft or merge the values. And we're grafting it, so we'll sort of add both of them, right? And so do our merge, and that's more so we can sort of know the order of everything. We're actually going to make this, instead of going to 1, we're going to make it to go to 0.5. We'll just commit those changes and plug that into here. Come back and graph this. Now we have like 2 values each one, and plug that into the value. And so now, whereas before we had 1, now we have 2. And so that's going to be important for us to have like that sort of slide 2. And we of course could change that relationship, but I think that's a good set of value. And so that's our function for rotation, and this is our function for how wide does that curve go out, right? And actually that's the domain. We want to make sure to bring our value right here. So really our sine function is more determined from here. And because we're talking about sort of that amount, I'll just go ahead and make sure that we're focusing here. So this is our value that was multiplying times the sine is going to be, actually that's our slider for our rotating. And we made it the same so we can have that center point, but we're not using that any longer. Essentially we can expand it here, right? And this other value was sort of just the domain. We didn't really use that. But we have the ability to make that wider or smaller right here. Okay, and it's a nice little division across there, so we can create surfaces out of all these. All right, so this is all just working on our sine function. Now we'll do our shifting function, where we just rotate each of those values over a little bit. And so when everything's in the domain, we're not getting any issues here when we're evaluating the curve for those points. And again, when we're gonna come back out and get those values, you might flip the domain, so we'll be making sure that we're getting our surfaces from the proper loft. All right, so the final thing we're going to do with this is we're going to go ahead and shift these, and so that's our shifting function. Okay, to shift our domain, we're going to do a similar functionality to this. We're just going to take our domain that we've started here and just really shift it over a particular amount. And so because again, I want it to go between 0 and 1, I'm just going to do a simple number slider. And I'm just sort of saying how much do I want to shift it, right? And I wouldn't shift it the whole amount. So I'm just sort of keeping this value down. And what I'm just really doing, and it's easier this way. We're going to be just like we were sort of rotating, rotating in here, so to get the other one, and we're making sure that we're able to keep that rotation in. Now we're just adding a shift in. So this value is very valuable to just be multiplied and remapped just like the other numbers. And we'll just sort of just plug that in. So this is sort of like a default remapping to the domain. And this would just be a value that's going to be added. And okay, here's a difference about this value. I'm going to actually separate this from here. It's going to be shifted per level. And we could go ahead and take our same function that we used for our series here and just saying this, because we're like doing a progression. So each level we're going to move it up just a little bit over, right? And so that's this pretty much my starting point to my end point is going to be really a maximum of this. And sort of to keep that sort of clear, what I'm going to do is I'm going to use a dividing function, and I'm pretty much going to divide based off just like my list length here is my particular shift amount, and I'm going to take that in, and that's going to be my step. So that's going to just be easy how much it steps out from, and it's going to start from 0. From this one actually is fine to start from 0. And you see at the end of that, it's just very minute values, but remapped across the domain, it'll be a significant value. So we're going to shift that into here, and I'll just plug that straight in here. And so now this is going to be an added value, and we'll just pull this out here. We can go ahead and pull back the one we're not using. And this will, of course, be a group when we conclude here. Just have some space. And what we're going to do is now, just like we've done sort of here, is add our plus here. And of course, this is going across all of these, so it's not going to have an issue. We could even, sort of even like we've had here, if we want to split it up, we can also just even split it up here. But we're going to, it's fine for us to do it a little bit later. We're just avoiding multiplying too much by using merge and working with trees. But we'll just be adding, like I said, our mapped addition value. This is in our shift function. We'll just go ahead and copy this down here so we have it clear. Just label that. And from our shift function, we'll just go ahead and just group it so these are nicely organized. And add that into that group. That shift function will be just an addition, and I think it'd be fine to just sort of even, just for the purpose of just understanding which value is which, I'm going to go ahead and just keep them sort of in their own trees, and just really now we'll come out and just we want to make sure that not to mess around too much with trees. If we want to deconstruct a tree, it's not going to be impossible. If I would just want to get that started, I could just be working with list first and foremost. And since this is sort of just divided in two, I could just be doing list item. We'll just come down here, and if I sort of said just the 0 part of this list, I would sort of be breaking that down. One way we can also sort of do that is because it's sort of, let me go ahead and just see it here. This is just the value right here. It's not really going to be that easy till I get it here. So it's really just taking one at a time. And that's because it's sort of in the wrong sort of order. If I want to flip a domain, I can always just come over here and just flip the matrix. And so it definitely sounds cool. But now what I have is a bigger list. And so the idea is I would just divide that into 2. And so now you're starting to see where I could have just individual paths for both of these. And so this is avoiding me sort of duplicating too many forms of information. And so now I have 4 of these, and each one of these I'll just go ahead and merge it again so I can make a bigger sort of tree. And the idea is just like before where I was putting things in and merging, you know, I can just graft it, and it's going to be just going to make it easy that way. But I'll take this in, and now we're actually going to minimize having too many evaluate. And the idea is, which is important, again, just like we saw for the particular curves, and we need to make sure that it's matching. And so the first point is going to be with the first curve. So that's going to be important here. And so this domain list, which now we'll really have it as it's supposed to grafting this one. Pretty much each one is 2 of these to 1 of these. Now it's going to be a little bit more, but now we're going to do this cross function 2 here, and so it's going to be that same sort of value at the end. The value is 48, 48. So here it is. We got 4 values going in each here, and now the way we would do that is, again, because it's again, it needs to match for trees to work out properly, and we're just sort of adding per level. And so one way is sort of to see all that is 1, 2, 3, 4 points needs to be sorted. So we always can use something, a function like this, duplicate data, and that's one way that we can easily sort out the concept. Or we also could just sort of like reverse engineer and use merge and just duplicate that value times 4, because it's 4 times going in, right? And so right now it's not yet a tree. When we graft it, we can sort of put it together on this side. So we'll just graft it on each one of these. And so it's going to be matching, and we can look at those values. This says 192. Now this says 192. Now these are equal, and so now we have this. And the only other thing now, of course, is we will need to do domain control. Again, this has to match with this and sort of how it's organized, and that might be sort of a function of like each 4 of these is going to be added to 1 of these. And so the idea is, sorry, this is actually placing this one. So the domain here, all these have to match sort of with here. And so because it's n and 4, I think everything is also properly set up. And this is sort of showing us we sort of not yet connected until we maybe graft this value. We'll just do what we need to sort of make sure that it's actually going to the right element. And actually, because the domain is matched to this, we both have to graft here, and then we have to graft here. And when we do that, you'll see all of our functions, and we'll just sort of find out what's sort of going on here. We want to make sure that we're not using any old values, and we're not, and we just have an additional function here because we previously were doing it in 2 places. But now, since we decided to use trees, we can go ahead and disable those functions, and we just have everything working in with trees. Okay, so the next thing we want to do is just like we have here, we just play around with our shift function to find out what that shift does just directly. And we see that, and it's just pretty fun, right? It's just going out, and it's all in domain. And so the idea is you can already start to think about how this is going to be splitting this functionality. It'll go across, and it has like that internal area that's going to be connecting. But we have to split the curves, and that's where we start to get in the world of making our plates. So that's going to be our next work for this element. And what we're going to do also is, because again these are a little bit sub-function, we're going to pull this down, and we'll turn this set. We're not actually going to include the scribble in. I'm going to group this, and we'll just make sure that we have a clear set of outputs from here, so we know that. And this is just our surface points, and we'll just put this in here, and we'll just label it points. And make sure that's enabled. And so that's our surface points, and they're grafted, so you can't really just see them. But we will pretty much unsplit the tree so we can start to divide these curves and get some key information to make the plates and to make the pattern.